When we have a system of equations, we need two variables and two equations. But we can extend that idea and say that if we have three variables or three unknowns, we can solve for a unique x, y, z if we have three equations or three relationships that go with it. So in this case here, we have a system where we have three variables, three variables, three variables, and we have three relationships. We can solve this system, and we can do this by systematically eliminating variables. So let's take a look at this one here. And we are able to combine any two equations to be able to eliminate one variable. So if I combine a and b, we can actually get rid of the x variable. And if I combine b and c, I can do the same thing. And so I would end up with two new relationships that would involve two variables, just y and z. So let's try this. I'll show you how this works. So I'm going to take equation A. So I'll take equation A and equation B, and I'm just going to add these two together. So x plus y minus z equals 0, negative x plus 2y plus 2z equals 5. And by adding these two together, we're going to end up with 3y plus z equals 5. So I'm going to call this equation 4. So this is a new relationship that's different than the three previous ones I've given. And we'll do the same thing with equation B. So I'm going to do 2 times equation B. And in doing so, I'm going to match the coefficients on the x. I just have to be careful to keep track of all the coefficients, that I've doubled all the coefficients in B. And if I take equation C, 2x minus 1y minus z equals negative 1, if I add these two equations together, I'm going to come up with a fifth equation that's different than the other. So I've combined A and B, B and C. This is a different combination, and it generates another equation. In this case, I'm going to have 0 x's, 3 y's, 3 z's equals 9. And so I've generated two new relationships that have two variables, both the same variable y and z. I can now then, basically what I've done is I've combined these equations to go from a 3 variable system and 3 equations to a 2 variable system with 2 equations. And I can then take these two new equations, equation 4 and equation 5. Now since the coefficients already match, I don't need to match coefficients. And I can subtract these, and what this will do then is it'll reduce it down to the one variable, one equation. And this will allow me to solve for z. Well, once I've solved for z, I can solve this 2 by 2 system here for y by substituting back in for y. So I can either choose equation 4 or 5. I'm going to choose equation 4 here, and I'm going to substitute in the z that I solved for. So 3y plus z equals 5. Plugging in my z value, I can rearrange this and solve for y. So 3y is equal to 0. So I get y is equal to 0. And plugging that back into one of the previous equations, one of either A, B, or C. In this case, I'm going to substitute into equation A, x plus y, which I solved for to be 0, plus z, in this case minus z, is equal to 0. I can then solve for x, So I end up with x minus 2 equals 0. So I've solved for now x, y, and z. And I can check this by checking my equation. So 2 plus 0 minus 2 equals 0. That's correct. Negative 2 plus 2 times 0 is 0. Plus 2 times z. 2 times 2 is 4. So I get negative 2